He's shopping.
All right. Okay, so here's what we're gonna do. We're gonna start, Drew, y'all. We're gonna start with the more broad of our options here. Is this going? I told it to go. Yes, it did. And we're gonna start with our review here with the PowerPoint slides, and then we'll move to Jeopardy. Okay. So I know some of you mentioned that you couldn't get the little concealed answers to unconceal, and that totally depends on what software you use to open the slideshow. If you're using PowerPoint, it should animate, but if you're not using PowerPoint, if you're using Google Slides or any of that other stuff, it may or may not. That's why you had the separate version that didn't have any concealed answers. Now, this one is similar to the one you've been doing, except it is shuffled, so the slides are not in the same order, and it's narrowed. So a lot of extra slides have been taken out of here, meaning they were extraneous. You probably studied them good because you should know it, but you're not going to be tested on them. So the stuff that's in here is definitely stuff you should know. And then the stuff that's in Jeopardy, 100%. Real quick, because I'm always asked. There are 34 multiple choice. There are 1, 2, 3, 4, 5 diagram. 3 short answer on the second page. There's a labeling diagram that consists of 1, 2, 3, 4, 5, 6, 7, 8, 9. Another one that adds 10, 11, 12, 13, 14, 15. There's a short answer. What are you giggling at? 1, 2, 3, 4. There's 4 more short answers. Some of these are paragraphs. Or another 4, another diagram, and then extra credit. I'm not telling you what extra credit is because that takes the fun out of extra credit. Okay. So we are going to stay in teams just so you can kind of keep it all together. And what I'm going to do is, do we have somebody who wants to score keep for this version? You want to score keep? So all it's going to be is when I come to a slide, we're going to start with this team. I'm going to give this team a chance to answer everything on the slide, everything. It may be one thing, it may be 5 things, you know how some of them are. And then you guys are going to have to, if you get it right, you get the 1 point for that slide. If you get it wrong, it's like a pop fly, they can catch it over there. And if they get it right, they get the point and then they move on. Does that make sense? Yep. Okay, so it's basically 1 per team.
Do you have a piece of paper I can write down?
Yeah, she's got her fun, but I'll give you paper.
Yeah, but I can do it for both teams.
I want to do it for mine just to be sure.
He wants to be sure that this is accurate and correct.
Yeah.
Will this work?
You think they're gonna take us to the court?
Right. And don't forget, if you have to turn in something today, like your outline and your citations and whatever, be sure you either put it up there, or if you put it in the digital file, that's fine. Yes.
Oh yeah, I was gonna ask for this digital.
Yep, everybody has their own folder in the Dropbox file. You should see your name when you get there, and that's where you stick your stuff, obviously. I will be returning, I'll go over your stuff, and when I go over it, I'm putting it back in your file, okay, in your Dropbox. So if I add any commentary or whatever to it, it's going back in, and I'm trying to do it all today to give you guys as much time as possible to make any corrections or changes or whatever, okay? Are we good? And I will let everybody know when they've all been returned. Let's start. So I'm going to just start with the team in the front. What are we? Team number 1, team A, team what? What are you? Team number 1?
7.
Number 1. All right.
Yeah, team
That makes you number 2.
No, we're team 7.
Okay, team number 1. Pick a person on your team to answer. I need all 3 boxes.
Why did everyone point?
She's chewing.
Hey, you're in the leader, Jay.
All right.
Can we please call team 7?
No, go ahead.
The first one is scientific method.
First one is scientific method, an organized plan for gathering, organizing, communicating information. Yep. Observation. Very good. Hypothesis. Outstanding. Give your team 1 point. And next team. So, Remember, this shows you that there's not always one way to get to your answer. Sometimes you have to move around. Oh,
you just-
That one just went. Sorry, I don't know why. Yeah, it may be elements.
Table salt.
So composed of two or more elements. Now you can't get, okay, wait a minute. Sorry, hold on. There's a problem. These are disappearing before I told them to, and I don't know why. They're not supposed to do that. Hang on one second. Does it look like- Are these gonna do it too? Shh, 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 shh. Guys, yo. All right, I think we've fixed this. All right, so this one should be easy because y'all should know it, know it, know it. Team number 2, what do we have here? Who's answering?
Come on.
Oh, no, why, wait.
Fill in the
Okay,
blank.
the blank. Okay. So scientific law tells what happens in fact. and
Mhm.
then Scientific theory tells why it happens.
That is perfect. If you memorize that and write down what Chloe just said, you've got it. Outstanding. All right, moving on. Oh, don't click that. Click here. Go. Okay, stop doing that. Why is this there? Go away. All right, team number 1.
Okay.
Somebody over here. Team number 1.
Alex?
Anybody? Caitlin.
I'm pretty sure.
Shh, shh.
Do I have to answer them in order?
Um,
I have them out of order.
okay, do them out of order.
Control is what you keep the same.
Mm-hmm.
Dependent is what changes, and independent is.
Somebody help her. You're on the team. Same team.
Why?
Say it, Caitlin. What you change. She's got it. Okay. What you change, what you observe changing, what you keep the same. 1 point. Heading back. Next group. Ah. Who's gonna take it?
I'll do it.
All right, Alex.
Okay, the first box is anything that has mass and takes up volume.
Right, it takes up space, which means it has volume, correct?
Element, a substance that cannot be broken down into simpler units.
Mhm. That one went too. Sorry. You know that one. Nucleus at center of an atom. What's the next one?
That's gonna be a neutron,
Mm-hmm.
and that's gonna be a proton,
Mm-hmm.
and then it's gonna be an electron.
Very good. Point for your team. Outstanding. Next team. Aha. All right, who's going?
Oh, okay.
Drew?
You want me to do this one? Okay, so 1 gram is equal to 1/1000 kilograms,
Mm-hmm. How would you do that as a decimal?
0.001.
Very good. Hey, come on, this team.
Statement, the mouse weighs.
Hold on. Okay, go ahead.
Statement, the mouse weighs 7 grams is an observation.
Very good.
In earth science, it's important to remember that the unchanging drives the change.
Very good. Very good. All right. Points for this team. So basically how we're doing it is team number 1. Y'all are team number 1. That's team number 2. You guys get the opportunity to answer everything on a slide. Then if you get it right, you get the point. If not, they get a chance. Same thing, vice versa. And you just trading back and forth. All right. Team number 2. We just went through like 3 slides. You didn't mention much. Okay. Oh boy, this is hang on. Let me get it to okay. All right. Team number 2. Who's doing it? Jack.
The first blank is the first one is an open system.
Mhm.
Both energy and matter, right?
Okay.
Next is a closed system,
Mm-hmm.
and then the third is an isolated system.
Right. And remember that an isolated system, is it real or is it?
Not really.
Yeah, not really. It's sort of a hypothetical situation, right? Very good. All right, coming back to team number 1. Woo! That was fun. Hang on 1 second. I'm gonna let the dog out of his little box here. And remember when you answer this question, when you answer, listen, are you listening? When you answer this question, you need to give all 3 points. All 3 points to the question. There are 3 main points.
Does anyone know?
Yeah,
No.
I know.
Okay, you know, okay, that's.
And assumes science exists in a binary state.
Uh-huh.
Natural science isn't about 100% proofs, and then assumes a poor understanding in one invalidates good in another.
That is perfect. Yes. So your number one, very good, is the binary state. If you can remember no binary state, right? Doesn't cross some magic line. That's your first point. Your second point, exactly like Bailey said, I don't care what order they're in. This is this poor understanding. Shh. Good or poor understanding in one area invalidates or supports good or poor understanding in another area. And then the last one, of course, is that not about absolute proofs. And your big term here is your narrowing uncertainty. Remember that, narrowing uncertainty. Okay, point for you guys. Team number 2. Your trick for remembering latitude and longitude, it has to do with this little ladder. Ah, sorry, that one went. Okay, who's gonna do it? James? What now? There's a song. Okay, yeah. There may be, but what with? Mhm.
Longitude is long ways.
Yeah,
The latitude is
this steps on the ladder. You got it. Okay, I like it. Back to team number 1. All right, this is a big one with a lot of stuff. So, international dateline.
What?
The international dateline is an imaginary north-south line drawn through the middle of the Pacific Ocean about halfway around the world, close to 180 degrees of longitude from the prime meridian, which cuts through where in England? Greenwich is correct. Okay. Now, what I want you guys to remember about it is that it is not enforceable by law. There is no like international law to enforce the international dateline, but that it zigzags. Somebody on this team over here in team number 1, tell me, why does it zigzag? Piper.
The smaller countries want it only to be time zone area.
Right, there's islands and stuff that it jiggles around. So if you can remember that it's to make things easier for commerce, business, life in general. You don't want to be in a different day than your next door neighbor. That would be fun, right? All right, I need chemical reactions. Okay, you guys come up with 7 signs.
Okay, so.
Color change?
Shh, not you. Shh.
Hey, I'm sorry, I forgot. Let's take that into account.
Think about it in case they don't get it.
Smaller temperature.
Yeah, that's all. Okay.
All right, what do you have?
Okay, so we have changing color.
Uh-huh,
Emission of light,
okay.
creation of a gas, creation of precipitate, sound, change in heat. What's the last one I was thinking?
Change in temperature, yeah. That's it. You got 7.
That's 6.
So odor. Oh yeah. I thought he had 7.
No.
I counted him wrong.
6.
Oh, I counted. Well, oh, that's my fault then. Okay, so production of odor, formation of precipitate, evolution of gas, change in temperature, production of light, production of sound. That's the one people tend to forget. Absorption or release of electrical energy. Okay, got
Okay.
those. And for your exam, just so you know, you have to give me. I think you have to give me a certain, well, I'll tell you in a little bit because I'm going to go over it with you. Okay. Alrighty, team number 1, what have we got? What's the atomic number and the mass number?
This is our team.
Right.
About.
Guys, step. Who's got it? What's the atomic number mean? And what is the mass number or atomic mass? What's that mean? Mass number is atomic mass, same thing. Another term.
Yeah, that's our, it's our group.
Say something.
Atomic number is the number of protons.
All right.
Shh.
Guys, hang on. Stop. All right, go ahead.
And yeah.
Okay. So atomic number is the number of protons And atomic mass is the number of protons and neutrons. It's the mass of the proton. Yes, some of them basically, which is their mass. So that's good.
You're the ones that have that.
Yep,
So-
exactly. So Bailey answered the rest of that. The reason the electrons aren't included is because why?
They have so little mass.
Like negligible mass. Yes. Did you have a question? Or are you good? Nope. Alex?
The mass number does take into account isotopes and their frequencies, which is why
Mhm.
it's not a perfect
Yes.
whole number.
Yes.
So, yeah.
Yep. So yes, sometimes you have isotopes that are more common than others. So that it's kind of an average of all of that when you stick it all together. Alrighty, team number 2. Mixtures and solutions, the change of one or more substances into other substances. Blank is a material made up of 2 or more different chemical substances which are not chemically bonded. Each substance retaining its own chemical properties.
Where did you get that picture? It's really pretty.
I don't know, I just randomly Googled pour paintings or something, I think. Yeah,
Okay, pour painting.
the pour paintings, where you pour.
Like pour paint.
Ah,
Oh.
and then you have homogeneous mixture. Okay, are you ready? Team number 2, what you got?
First one is mixture.
Okay,
Second one is solution.
all right.
The third one is solvent.
Mhm.
The fourth one is solute.
Very good. So a solvent does the dissolving. A solute is what is dissolved. Remember these, okay? So you've got solutions, mixtures, and what was the other one we did a minute ago where we talked about 2 or more elements together and they combine completely chemically? That was what, James? Yeah, there you go. All right, so that's what you're thinking of. All right, let's see. Team number 1. Acids and bases.
Okay, the first one's acid, the second one.
First one is acid. Acid produces hydrogen ions in water and has a pH below 7. Bases produce hydroxide ions in water and have a pH above 7. If I didn't tell you what the pH was, would you remember which one produces hydroxide and which one produces hydrogen? Yes.
Yeah, plus it's the opposite.
Well, I remember.
Wait a minute, hang on. What, Bailey?
So the one that's the positive is actually below 7.
Yeah, the positive is below 7. Yeah, yes. If you think of it like a flip-flop.
What you need to do in order to get to 7.
Yeah, that. What you need to do is be able to get up.
To get up to
You have
7, add or subtract. There you go. That's a very good way to put it. Yep. I've also, there's something about, this is weird, but there's something it has to do with like the shape of the letters. Like this is a pointy letter and there's a plus. I heard that too. Whereas this has like 3 rounder letters and there's an O. I don't know if that helps anybody at all, but there's that. People see all kinds of things. Alrighty, what is this? Team number 2, y'all should know this in your sleep. Law of conservation of energy states, James, there you go, perfect. Anybody remember the story of Amélie du Châtelet? Anybody remember about her? I said she was the ultimate party girl.
You're the one that like killed the what was it, the horse, the elephant?
No, that was Edison.
Didn't she have like 2 husbands or something?
Yeah, kind of in a way. She had a husband. Do you remember who she was shacking up with all the time? Do you remember?
I think it was some French dude.
It was Voltaire. Mm-hmm. French writer, philosopher. Yeah.
Some French dude.
And do you remember why she died?
Various.
No, you would think. No, it's actually she had she died as a post-maternal
Oh yeah.
illness infection, right? Okay, she had the baby and then that was it for her. Oh, those went away as soon as I clicked for some reason. So know this. Yeah, y'all know these, right? Evaporation is liquid to gas, condensation is gas to liquid, sublimation, da-da-da. I'm gonna make sure that these don't do that again, because that is dumb. I don't know why they did that all at one time. Something about these.
Remember the solid of gas.
Yeah.
Because they both start with S.
Yes, okay, there you go. So yes, the solid to gas is one people forget frequently. That's your sublimation. And then deposition is your other one that people have trouble with, gas to solid. Okay, let's see. So now we're back with you guys. Alrighty, what is this? Mineral color is determined by primarily what that make up the mineral's composition?
Yeah, minerals is already up there, so I would.
Mm-hmm.
So it would be elements.
Go for elements? Elements is right. Okay, let me ask you this. Team number one, are minerals organic or inorganic?
Or inorganic.
Inorganic. Why?
I was saying that because they're not.
What's it mean to be organic?
Derived from a living,
Yeah,
derived from a living thing.
derives from a living thing. And what do all organic organisms or organic
They were once alive.
substances? Yep, they're once alive, and what do they contain? Carbon, hydrocarbons specifically. Yes. So if you were asked a question on your exam about whether or not organic substances within minerals impacted their color, how would you answer that?
False.
Yeah, that's not the case, right? Because they don't have organic substances in them. All right, great.
Like it's like a bone formed inside of the mineral.
Beep, 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 beep.
Like as it's melting.
Boy, oh boy.
Bone formed or something.
And here we go. All right. Yep. 1 second. Hold on 1 second. There's a something there. This one's not showing up. Hold up. Let me make sure that they don't do anything stupid on there. Here.
Totally accurate. Yeah.
Okay.
Feel your nose, Bailey.
So that's scary. All right, so let's look at this first. Before we answer them, we're gonna look here. Shh. So texture of a rock, Lily, are you with us? Texture of a rock is how it looks and feels, right? And it has to do with grain size. You've got coarse, fine, or no visible grain. Then you've got grain shape. Is it rounded or is it jagged? And then little note, igneous rocks do not possess rounded or jagged grains. And then lastly, your grain pattern, is it non-banded or is it banded? Okay, so if you were presented with rocks that look like these, and you had to decide what kind of rock they were, igneous, sedimentary, metamorphic, what could you tell me about this rock? Team number 2, you're going, right? So start with this one right here. What is it and what do you know about it?
That's granite, it's an igneous rock, it's also used in countertops.
Okay.
All traces of radioactive
All the way.
Well, that's a lot of information, but yeah. Do you want me to shut it? Is it,
No, it's all the way at the top in the corner.
what is it?
It's stink bug.
Oh, gross. Yeah. right. Okay, team number 2, what's this one here with the fine grain?
One moment.
If you don't tell me the exact type of rock, that's fine, but I need to know what you know about it.
It's definitely a fast cooling igneous rock.
Mhm. Which of these cooled fastest?
Obviously the far right, which is obsidian, by the way.
Okay. Which would be igneous. Very good. Perfect. Uh-huh. Wait a minute, Bailey.
Know the types of like the names of the rocks or.
No, I don't expect you to know the names of the rocks, but I'm gonna want you to be able to tell me what type of rock it is. Like which are igneous, which are metamorphic, which are sedimentary. You will need to identify 3 of them. The obsidian is one. You already went over that. There's 2 others you're going to need to identify, and there are very obvious ones. It's not, I'm not gonna throw like this one at you
Okay, that's what
or
I
this one at you, because these are not obvious. And if obsidian is one, then you're gonna have one in this row and one in this row. Okay, and these 2 are pretty easy to tell apart. And if I already told you I'm not gonna give you this one, then you know what the other one is.
The other just looks like a pumpkin.
That's
Rock.
very good. Okay, so where are we, team number 2? We're here. And
Yes, that, I believe, lumberite is
Mhm.
rounded grain, which means that the rocks have traveled much further.
yep, and it's
And
sedimentary.
it's sedimentary, formed by a variety of larger rocks,
Mm-hmm.
like gravel size or smaller.
Yep. And how about this one?
Sediment won't compact around them like normal I have no idea which rock that is, but that's definitely jagged, so.
Right. So that one's breccia. Breccia kind of sounds like a sharper word, doesn't it?
Yeah,
Sounds like a sort
it
of
sounds
word
like.
snag.
Yeah, it's got those hard consonants in it, the C's. So you can think about it as, this is the chopped up one, right? This is the one with jagged edges. What's the other word, like the colloquial term for conglomerate up in Michigan, where they find tons of it along the lake shore, do you know? Anybody remember? Pudding stone. Yeah, I don't know. All right, and so lastly, how about these on the bottom?
Those are definitely metamorphic, the one on the right, I know more about, but the one on the left, I'm not really sure which that is. Appears to have a high iron content, just in color.
So it's quartzite, but it's metamorphic. Okay, and then what's the obvious looking one here?
Nice.
Yeah, okay, here's how do you remember. If somebody gave you an Oreo, handed it to you,
Nice.
what would you say?
Nice.
Nice, thank you, nice. That's exactly what you'd say.
I would not be able to, but that's how it's said.
That's what you say, nice, right? Right, and this one looks like it's, to conglomerate, like a conglomeration of people is like a big old crowd, that's what this looks like, so. You what? Oh, sorry, you had a question? Don't take nice for granted. That's a great one too. All right, so team number one. So rate of weathering, chemical weathering rates versus physical weathering rates and temperature. What's our relationship here? Who knows it? Okay.
Okay, so chemical weathering rates are increased at warmer temperatures, while physical weathering are increased at cooler temperatures.
Okay, and why is that, Drew? That's correct, but why is that?
Well, because like in cooler temperatures, you have things like glaciers, which can cause a lot of physical
Mm-hmm.
weathering and stuff like that.
Yeah.
And also like water instead of rocks when it freezes, fans break.
Yes, that's the big one right there. Water, guys back there. Yeah, don't distract. Water expands when it freezes. So if it gets into a crack, this is what happens. That's what caused that. And then what were you saying about higher temperatures and chemical weathering?
That is, I guess, just like acid and stuff like that.
Yeah, chemical reactions in general, temperature raises the activation energy for a chemical reaction, lowers the activation energy for a chemical reaction. Yeah, what were you gonna say, Alex?
That dripstone.
Stalactites and stalagmites, all that fun stuff. Yeah. So yes, if you increase the temperature, you lower the activation energy for a chemical reaction, which means it can happen more easily and more quickly. If you've got it cold and your water expands, you got rocks cracking apart. Okay, here you go. Just look at these for a minute. Okay, you've got your coarse grained rocks, your medium grained rocks, fine grained. What's this one? We didn't talk about this one before. What is it?
Sandstone.
Sandstone. And yeah, it's sandstone for sure. So what kind of rock is that? Yeah. All right. So let's see. Team number 2. All right. Now, this important thing about this one is not just to describe what they are, but to know the order. Know this order. And there should be one more right here. You can tell me what it is when we get to the end. So you have to tell me a little about weathering. What is weathering? What is erosion, deposition, compaction, cementation? All right, James, you gonna go for it?
Process of breaking down.
Mm-hmm.
Erosion, process of moving sediments that are broken down.
Right. Mm-hmm.
Where sediments are laid on
Mhm.
top of the sediments. That's together.
And what's the very last step that should be right here? Lithification. I don't know why it wasn't there. I thought it was. Maybe it did it. Hold on. It should say, look at that. It's missing the word. Let me stick it in there where it's supposed to be. Yes, it should say lithification there. And yes, lithification is when you get everything done and it's all brand new rock, right? Look at that.
Oh,
It decided to be all capitals. That's not fun. That does look really frightening, doesn't it?
Wake up and see
That's
that.
demon. That's demon.
There you go.
Yeah, wake up and
All
see
right.
that on your wall.
So next we are going here, team number 1. Stream networks, networks that collect fresh water, run off from the land and carry it to the ocean. Water, all the land, what you call all the land that drains into a stream system. Piper? Watershed, very good. All right, team number 2. You're getting all that, yeah, I don't know how that happened. Okay, Drew, y'all, don't look like parrots, that's weird. All right, tell me what we've got here. Team number 2. What is it when you have these small particles are held up by turbulence as they're transported? What do we call that?
Yeah, that's it.
Look at the picture. The words are all in here, so you got to put them in order. Yep, that's your suspension. Mm-hmm.
Then the next one could be interaction / surface creep.
Okay. Bed load.
Oh, that can be pushed, okay.
Okay, wait. That means I have to pop fly it over here. Do you guys know the next one?
So the salt minerals that are transported is the same, both the top and bottom are the same.
Oh, bouncing back to you guys.
So I was
Yeah, they're very similar. Yep. Small particles dissolve minerals.
No,
No, the two are the same exact thing.
Oh, they are. Yeah, I don't know why that is. Then ignore that. So, okay, so nobody gets the points for that one. Let me take that out. I don't know why it's in there double. I see what you mean. Yeah.
I didn't know that. I didn't know that one. I was just trying to point it out.
So real quick, aside from this type of water, look, they circle a minute ago. This type of water erosion, what other type of erosion is pretty much analogous with this? Drew, do you know?
Well, yeah, say wind erosion because it's also fluid.
Right, exactly. That's what we're looking for. Okay, so you guys are up. Alrighty, what do we have?
I know you said it was 71% nitrogen. 71? Yeah, 71 and then 28% oxygen.
Oh, 71, 28? 78, 21. Oh, and there's other gases too. So everything else is in this 1% roughly.
No point for you.
Okay, you guys are up. What are these?
Oh, esters.
Oh, Eskers, he says super fast, and he's right. Very good. Hey, next up. All right, you guys explain to me what's the difference here. Weather and climate. Lily, you can do it. What's weather and climate? You know it. Yeah, it's your turn. They just went. Yep.
They got us.
Lily, Sky, Liam, somebody who hasn't answered yet. You know what the difference is. Help her out, Drew.
Look at the graphs.
Yep.
Weather.
So what did you say?
Weather is day by day. No, climate is day by day.
No, weather.
Weather is day by day and climate is over time.
Right. Short term versus very long term. Climate is over roughly a certain number of years. Do we know what that is? Do you know, James? It's roughly 30. Very good. All right. No. Okay. Did-did-dip. Did-dip. I don't know why these are doing like so. Oh, that's screwy. Hold up.
I know what the answers are.
This is weird. Hold on, let me make it so that this stuff doesn't move because I thought it was all set and apparently it's not. No. Go away. Yeah.
Really? Don't show everyone around. Yeah, they just use it so that
Anything to do with those.
The children are so funny. You're like, I don't want to do it. Got nothing to do with me.
It's January.
Yes.
I was like, so.
Okay. All
Okay.
right, who's up? You guys were up, right? Okay, guys in the back. So what do I want here?
Okay, so one of the lines is gonna be heat.
Mm-hmm. And the one on the right? Okay, so heat is the transfer of energy. because of a difference in temperature. And what is temperature a measure of?
How fast the molecules are bouncing about.
That's exactly right. Remember that temperature is a measure of how fast particles are moving, and heat is basically the transfer of one to the other. Heat is what you feel, temperature is the reason you feel it. Okay, air pressure and density. Where are you going? Boop. These are all kind of funky. Oop, ah. Sorry, we'll stop at that. Nope. Okay, we'll go there. All right, team number 1. Air pressure. You are used to the pressure that the air exerts on you. Fish are adapted to live under pressure of the water. Pressure what with depth in the ocean? Piper? As you get deeper into the ocean, what?
That was
We'll find out
it reveals
later.
the one first, the popular one.
Yeah. So what's going to happen as you get deeper with pressure? Yeah, it's going to increase. And then what happens as you get higher on land? It decreases, right? Okay. So again, if you're in, let me ask you this. If Becky and what was her name? Jenny. Becky went to visit Jenny. Was that how it went?
Yeah.
Where did Becky live?
One was in Denver.
One of them was in Florida. No, one of them was in Denver. No, not Florida. New Orleans. Right. Why did I pick New Orleans for that example? It's at sea level. Remember Katrina? Oh, yeah. Y'all don't remember Katrina. You weren't alive, but I'm sure you've seen the pictures. 2005.
Oh, yeah, that was
Yeah, because Cole was a newborn when it happened. All right, so listen. If what? Oh. Oh yeah.
not know that.
Is that-
Tortillas fall on. He's like, hurricane.
All right, so are we listening? So if you'd gone to visit your friend in Denver and then you flew back and landed in New Orleans and your shampoo bottle was all squished, but other things in your suitcase like a snow globe were not squished, why would you suspect that would be, Drew?
Because, what were you gonna answer?
Go ahead. Somebody, Caitlin? Go for it, Caitlin. Why would that be? Guys, Alex. So the atmospheric pressure on the outside, guys back there, the outside of the shampoo bottle is going to be greater than the atmospheric pressure on the inside, because where did that air come from? The inside air. That's Denver air, right?
Denver
And Denver air has it's less dense than New Orleans air, right? So if you were asked to give a very thorough explanation for this situation or a similar one on your exam, you'd be able to do it, right? Okay, good. All right, so back there, what's the study of atmospheric phenomena? Comes from the Greek word meteor, which means high in the air. What do we call this? Meteorology. Okay. Team number 1. What's this? Earth rotates from east to west as it spins. Caitlin. Coriolis effect. Very good. You guys have unfortunately really missed out on these merry-go-rounds. They took most of them out. Anybody ever been on one yet? Yeah. Old Park, probably right. Yeah.
McDonald's.
Oh yeah. See, the goal was to throw your friends off of this. If you didn't hit the ground, somebody didn't hit the ground, y'all failed big time. All right, moving on. Okay, team number 2 back there. Rising air is associated with what kind of pressure, and sinking air with what kind of pressure? All right, somebody tell me what's going where. And tell me about these blanks.
Wait, which one's talking first?
I think this one. I'm not sure.
Okay, that far left box should be low pressure.
Okay.
And then the right one in that box.
Okay, so rising air is associated with high pressure
Okay.
and with low pressure. Okay. And then sinking air is associated with high pressure. So in what kind of a system is air sinking? So when it finally hits the surface of the earth, it spreads out and pushes everything away.
High pressure.
in a high pressure system. Okay, and then bing, bing, bing. And then obviously this is gonna be a what?
As air forms, it creates space beneath it that is usually filled in by dense, cooler or high pressure air.
Yeah, it's gonna be as it rises, which is warms. Yes, that's what's going on. You get colder air. Colder air is more dense. Where do we see the same type of currents with dense and with things of portions of different density?
What is the mantle?
Oh, that's true as well. Mantle, there's another one other one.
Are the oceans.
There you go, oceans. Yes, because the more dense, colder water is gonna sink, push the warmer water up to the surface. That's how we get currents, because they're both what? Fluids. All right, number one, here we go. Sounds pretty familiar. I think we just talked about this. Drew? Shh, guys in the back. Definite density differences is the main cause of ocean currents because, or layering, same, I'll take either one in this case because it's actually true. Because cold water, which is more dense than warm water, sinks to the bottom while less dense warm water is found near the surface. What kind of water masses decrease in temperature and sink in the winter? Decrease in temperature and sink in the winter.
Yeah, it's like water sinks.
Notice it talks about salinity and density.
Like then, saltier water,
Okay,
heavier,
it's called intermediate,
okay,
but okay.
okay.
And
They're found in polar seas, and then the coldest, densest is Atlantic bottom water. No, Arctic.
you got it.
It is Atlantic?
Antarctic. You had it. I'll count. You were darn close. All right, that'll be good for the purpose of the slide. And then salt ions are concentrated in water under the sea ice, and it's due to this blank density of water near the ice. Do we know? Salt water, basically, we're talking about saltwater ions concentrated in water under the ice. So this blank, the density of water near the ice. They're thinking. So salt ions in the water under the ice are going to have an effect on the density of the water near the ice.
I don't know.
Anybody? You want to pop fly it up there? What?
Yeah, it increases the density.
Okay.
Raises. Yeah. Okay. That's good. That's good. Oh, yes. I'm gonna give both teams a point for that because you guys got 90% of the slide. All right. Team number 2. Here we go. What do we got here?
Okay.
Let somebody else over there answer. Milo or Parker haven't answered anything yet. Jack, I think you answered once.
Yeah, Parker.
Guys, don't get so loud. Think about it. You can help him. All right. Okay, what's this first one? High tides are caused mainly by the blank on Earth's ocean waters. Perfect. All right. Tidal range, the difference between levels of high and low. The greatest tidal range occurs in the Do I need to pop fly it?
Yes.
Wait a minute. What? At the equator? Bay of Fundy. Oh. Do you remember that when we watched The Living Sea?
Yeah.
Do you remember?
It was like all over.
Yeah. Yeah. I'll let you keep it because it's only one, and I let them keep it when they got stuck on Antarctic bottom water. So, okay, what have you got for this last bit? Sun acts in the same way as the moon, but has less influence. What are high tides? High tides are higher and low tides are lower. This is what? high tides are higher, and low tides are lower. And then we have one with high tides are lower and low tides are higher. You got it, Jack?
Oh, the first,
Okay, what's the first one?
springtime.
Spring tides, all right. James, you know this one, what is it? I know you know it. You've answered it before. He's like, I don't know.
He's thinking, go back to reflecting.
Spring tides and I'm gonna pop quiet. Okay, you guys? Nope. Neap tides. All right, good deal. So let's see. You guys got 1, 2 of these. I'm gonna give the point here.
Got 3.
Oh, you got 3? No, that one you missed. Bay Fundy one. All right. So, oh, you get 3? Okay, I'll give you each a point. Each team a point. Okay, sea floor spreading. There's nothing here to answer, but I want you to understand the process. You've got your mid-ocean ridge in the middle of the Atlantic Ocean, right? And as your magma comes up, it's getting pushed outward, right? Okay, now, magma that cools and forms the ocean floor is rich in iron. When the magma cools, the grains in the rock line up with Earth's magnetic field. Paleomagnetism is the idea that rocks acquire the polarity of the Earth's what at that time? Yeah. Magnetic field. You're right. Okay. Now, we know that the Earth's polarity has flip-flopped, right? The North Pole and the South Pole have flip-flop polarity. And keep this in mind because there's going to be some others that come back to this concept. Remember, this important concept. This is the video that goes with it. We're not going to watch it. Understand it. Okay, so now we're back to this idea. We're going to combine them. So team number 2, right? Who's this guy, this German scientist that noticed?
Our turn. 'cause they
Oh, it's your turn?
they answered
Oh.
the question.
You just,
Oh.
right? She answered that. All right, so team number 2. Who have we got here?
The first one is Alfred Wegener.
You know, he said Alfred Wegener, right? And he noticed that the coastlines of South America and Africa look like a puzzle. Anybody know the year? Ah,
I know.
you don't have to know the year for the test, but it's 1915. The important thing about understanding that it's 1915 has to do with how his theory ended up being proved, right? So these two were off. So continental drift, continents had once been joined to form Pangea. I don't know why those two are there because they're not covering anything. Whoops. And he hypothesized that over the last 200 million years, they slowly broke apart. I'll move this so that you guys can, if you're practicing it at home, you will actually have something to, okay, then you have something to click on if you're actually able to clink. There you go. So keeping that in mind, now remember Wegener had some data to support.
Do you want to move the one that's supposed to come necessary? Well,
Yeah, that would be good. Look at that. How did they all get scooched? Okay, so Mosasaurus, obviously we're not gonna count that one. Okay, so this was some of the evidence he used. So we're back on you guys. Obviously we know Mosasaurus. What's the other one? Traces of the same ancient fossils were found in South America and Africa. Do we know what that is?
it's a short word.
The short word. Hoplite, do you know? The crocodile, he's the Mosasaur, that's number 2. So I'll tell you, so it's just fossils. Y'all were making it real hard. And then your Mosasaur is this guy. Okay, remember who's the guy? Wegener, right? And Wegener had a theory that everything had been stuck together at one point, and he had evidence to support it. But why wasn't his theory generally accepted, Bailey?
Well, it was new and radical.
Wait a minute, she's answering. Yeah, he provided evidence that it had happened, but what?
he couldn't provide a reason for why.
Yeah, he couldn't describe what process might have caused this to happen, right? And this goes back to what we just talked about. On the ocean floor, we have what? Magnetic striping, right? The reason the 1915 is important is because it's before World War II. And in World War II, they were using the little minesweeping things on the ocean, all kinds of technology. So they ended up using all of this technology to get data, magnetic data too, from the ocean floor. And that's where the striping became visible for the first time. And then they were able to go, oh, wait, you know what this means? And they bounced back to Wegener. Okay, so coming back to team number 1. So Wegener also found evidence of similar climates on different continents and deposits of glacial sediment.
Wait, outer, they got popfly.
Yeah, but you didn't get it right.
So why?
Oh, no, you're right. It's your turn. You're right. It's your turn. Yep. Okay, go ahead. So what's this one? Deposits of glacial sediment on continents that are now in tropical climates. Do we know? You're like, why did we miss out? I don't know the answer. Popfly? Anybody? What'd you say, James?
It's just a statement, it's not a question.
Okay, so ancient climates, glacial till. This is not on the test. It's just part of understanding the data he used to get to his idea. All right, now we're moving on to plate boundaries. So we are at team number 1. Divergent boundary, a boundary where 2 reverse plates move away from each other. Ocean crust, what happens to ocean crust at a divergent boundary? Is what? Created. Give me an example where you would find a divergent boundary. Mid-Atlantic Ridge. Very good. Know that one.
Just that big one.
Okay, convergent boundary is where you've got 2 plates that are colliding. You got different types: ocean, ocean, continental, continental, subduction zones, and some oceanic crust. What happens? Team number 2? What's the word? It's subducted. Yeah, what happens when it gets subducted? Is it created or it's destroyed, right?
It just changed.
You get the idea.
form. It's fine.
Where would you find this?
Pacific mainly.
Where, what plate boundary would you find it?
Okay, there's one up in the European, there's one off, I believe, around east of the Himalayas. It's built into the Himalayas, by the way. Yeah.
That's the African Eurasian plate. Okay. The Himalaya area, the African. No, you're talking African Eurasian. That whole area right in there. Squish, squish. Is that what you're talking about, guys? Yo. Okay. Yes. All right. Okay. Yes. All right. So then, last question on this topic, you guys, team number 1, transform fault boundary. Okay, so transform fault boundary is a boundary where 2 plates slide past one another, but crust isn't what, Liam?
Created or destroyed.
Okay, where are you gonna find this? Where's a great example? Wait a minute. Yeah.
San Andreas Fault.
Yeah. That's your North American and Pacific plate. Perfect. Okay, now, dudes in the back. Convection currents. Okay, this is this continuous flow of fluid changes in density that has to do with both the material and the temperature, usually the temperature in this case, because we're talking about convection in particular. And oceanic crust is coldest and most dense farther away from the mid-Atlantic ridge. What do we call that? And then here you've got your mid-ocean ridges and the asthenosphere. It's elevated. Ocean crust slides down this elevation. What do we call that? Do we know? It's terms. It's definitely 2 vocabulary terms here. Oh, I heard one of them back there.
I'm trying to figure out which one it goes to.
Okay. Well, this one talks about coldest and most dense, furthest away from the ridge. And this one talks about how it slides down.
Okay, the second one's slab pool. but-
Mm-hmm. Well, this is your slab pull. You're right. It's getting pulled, but what's going here? What's this part? So that is going to be your ridge push. I'll let you have that one. Okay.
Wait, but why is
Hmm?
the slab pool the reason for it getting colder?
Because it's over here, it's being pulled and subducted. It's being further, it's getting farther and farther away from this thin spot. I mean, when it gets down here, it gets cold, but not here.
Why is it ridge push being pulled down?
Why, ridge, no, slab pull's being pulled down, ridge
No,
push.
the bottom, which is when it's getting pulled down.
This is your ridge.
Yes, you have ridge pull as the answer to the second one.
Mhm.
Which is it getting pulled down and subducted.
Yeah, oh yeah, hang on.
No,
I'll double check it, but I'm 90% sure those two terms are not on the exam. But yeah, you're right, take it back. Okay, age of the ocean floor. Ocean floor is blank along the Rift Valley of the mid-ocean ridge, and it's oldest in the subduction zones near what? Where is it youngest? Where's it forming?
At the mid.
Yep.
At the mid-ocean ridge.
Yeah. Okay, so then what about this one? Where is it oldest? Yes, yes, near the continents. Very good. All right, number 2 back there. Plate motion is caused by what?
Oh, I know this one. Convection currents within the mantle.
Convection currents. That's it. Okay, remember this. Again. Remember that. Okay, faults. Team number 1. Any fracture or system of fault fractures along Earth, or along which Earth moves.
Okay.
Okay, that's a fault. So what kind of fault is compression, causes horizontal and vertical movement? So look at these. Look at these pictures. Which one causes compression and horizontal and vertical movement? And then this one causes horizontal tension, sorry, causes horizontal and vertical movement. So there's a tension and a compression. And then this one involves shear. Yeah, that is.
That's cool though. That is cool.
that is really.
Mm-hmm.
So compression or.
So look at the images. Which one of these is showing compression that causes horizontal and vertical?
Probably be the reverse, 'cause it's
Okay.
going inward.
Yep, it sure would be. And then tension, which one is showing tension? Yes, normal. And then what do we call this kind?
So the,
What's the last kind? There's 2 versions of it, but it's a, yep, strike slip. Okay, there you go. That's what this is right here, right? Strike slip.
the reverse
Yep.
causes compression. and then,
Mm-hmm. What kind is the San Andreas? Strike slip. Very good. Okay, viscosity. Woo! Oh, no, it did that. Okay, never mind on guessing this one. Your high viscosity means it is thicker and slower. Your low viscosity means that it's thinner and faster. Okay, these are going to be weird, I think. We'll leave it like this. Very steep cinder cone mountains. So they're volcanoes, sorry. They're very steep volcanoes that result from material being what? Team number 2. Straight up into the air and falling back down around the vent.
Ejected/erupted.
That's great. Okay, and the second one? Magma and lava contain some what that make the eruptions more explosive?
Liquid ball.
Listen to Chloe. There you go.
Gas and.
Good job.
Water vapor.
Alrighty, team number 1. This is shield volcanoes. They're wide, they're gently sloping. They result from what kind of eruption of basaltic lava that builds up in layers? Yeah, okay. And then an example would be the Hawaiian Islands. What are the Hawaiian Islands formed over? Do we call that little area in the ocean there? You know? Yeah, that's the Pacific one. Hot spot is what we're looking for. Yep. Okay, guys in the back. Anatomy of a volcano. The magma that erupts to Earth's surface is then called lava. And lava erupts through an opening in the crust called a vent. The lava cools, solidifies around the vent, forms your volcano. Team number 2, composite. They did. Oh, I meant 1. I'm looking at you.
Okay.
Sorry.
Yes.
Larger version of a, guys, composite, larger version of a cinder cone that had been made of layers of what and solid material?
It's too short to be sediment.
What is it?
Ash?
Ash? What are you going for? You're going,
It could be ash, lava.
okay, lava, I'll take it. You said lava. Magma and lava, that make them up is, full of gas that builds up until it finally what? Yeah, erupts, explodes. There you go. Mount St. Helens is a great example.
It's not erupted in a while.
Not since the 80s. That's still pretty recent though. All right, dudes in the back. What's magnitude? Magnitude, amplitude, intensity.
Sorry, Oz.
Look at him, he's like, where do I go? They're all reaching. Yes, it is, but it's a good name for a gym. All right, guys in the back, do we want to give any of them a guess? Magnitude, amplitude, intensity? This is an earthquake. Talking about earthquakes in particular, measuring and locating. All right, I'll pop fly it. Team number 1, anybody know any of these?
So amplitude is how high it is.
Yeah, we talk about a wave, but in relation to an earthquake.
Okay, to an earthquake, I'm guessing it's.
I'll give them to you. Your magnitude is the energy of the largest seismic wave. Your amplitude is the height of the wave, like he said, that's correct. And your intensity depends mostly on the amplitude of surface waves, depth of focus. Okay, what's the focus, team number 1? And what's the epicenter?
Oh, wait. Oh.
Piper, Drew, one of you guys? Make sure you have the same answers. Okay. All right,
No, epicenter is
Oh,
what
epicenter.
you got it. Focus is where it happens, below the earth usually. An epicenter is the spot directly above it. Yeah, it's in the diagram. All right, you guys in the back. Who what? Isostasy. Yes. Okay. This is now be sure that you understand that there's a downward force of gravity and an upward force of buoyancy that cause this equilibrium, and the isostasy is this condition of equilibrium. Think about this if it is issued to you as a question. Do you remember the test that this was on, that a lot of you, it was a true or false? Do you remember a lot of you got it wrong because it said something like the downward force of buoyancy? Read it carefully, okay? Isostasy is right. Team number 1. All right, this should be easy.
Oh, okay.
In order from shortest to longest.
That's right.
Yep.
Period, era, eon.
Yep, it's right there in the little, graphic. Okay. All right, team number 2, explain to me half-life. It's the amount of time it takes for what of the original amount of isotope? Yep. Half of it. And then what are each of 2 or more forms of the same element? Sorry, this is in the way, but you know what it's getting at. What do we call these?
That's called isotopes.
Correct. And then what are we describing here? This is nuclear decay that occurs when the nucleus of an atom is unstable, spontaneously emits energy. What's this process? It's kind of in your answer already here. Yep, that's it. It's just decay. Okay, good. If I were to give you an easy math problem involving half-life and multiple choice, could you figure it out?
Yeah.
Multiple choice, yes.
Okay. So team number 1, what does it mean to place something in stacks one on top of the next, which conveys the idea that rock layers were formed this way over time? What's this word? Very good. Superposition is right. And using sedimentary layers of rock, to kind of map out Earth's geological history. What do we call this word? It originates from strata, Latin word. Yes, Caitlin, stratigraphy. All right. Team number 2.
Yes, gravitation contraction. As far
Wait a
as-
minute, somebody, Alex is answering all of them. Anybody else know over there? Or are we gonna let Alex answer them all? James, you know, Drew, shh. Okay, wait a minute, shh, I can't hear you, say it again. Particles combined, the increased size meant increased what and what, thus increased. Okay,
And gravitational.
okay, yes, so you've got, she said gravity, so increased gravity, increased pressure, and that means increased
Temperature.
temperature. Remember that this is not, what did you confuse it with?
Fusion.
Yeah. You guys confuse fusion and gravitational contraction. All right, cooling of the Earth. How long did it take? Earth cooled enough for what to form after 200 million years? What finally formed? Say it. You guys got it. Water. Good job. All right. Team number 2. What is this? Science of tree rings.
Dendrochronology.
What is it?
Dendrochronology.
Endocrinology. So you would know if I put something weird in there that's not dendrochronology, you would know it's wrong, right?
I asked this on Saturday, and one of the things was about that.
It was about dendrochronology? That's pretty
One
cool.
of the reading paragraphs was actually about that.
Interesting. All right, team number 2. Shh. Team number 1. We're gonna have relative age dating, and then we're gonna have absolute. I'm not sure what to click. So somebody just explain the difference between relative and absolute.
Relative is you put them in order without giving actual dates for when they were formed.
Mm-hmm.
Absolute, but you get actual dates from radiometric age dating.
Very good. Radiometric age dating for your absolute, and then your relative.
You put them in order with
Right, has to do with stratigraphy and superposition, and also, guys, come on, also fossils where they're located, like, okay, this fossil lived during this time period, and so this piece of land must be from the same time period. What do we call those fossils that help us?
Key fossils.
index.
Index fossils, key beds, index fossils. All right, here we go. Team number 2, paleontology is a study of past life forms, such as ancient sea life, dinosaurs, prehistoric plants. Fossils leave behind geological timeline of these ancient organisms on Earth, but are only contained in what kind of rock, James? Sedimentary rock, as layers, as the heat involved with what and what rock formation? What kinds of rocks do they not? Jack, what kind of rocks do you not find fossils in?
I'm sorry, Armstead.
Which are?
Everything else.
Nope. What are the other 2?
Metamorphic.
He's- There you go. Can't find them there. Too hot. Good. That's a great answer. Anybody remember this? Team number 1.
So that's 4 point, it's 4 point, either 5.4 or 4.5.
Okay. 4.54. Very good, Bailey. Okay, what are we basing Earth's age on? Yep. Oldest mineral is what? Zircon, right? Okay, yeah, you're good.
Space rock.
Yep.
Rock, the age
Called
date.
meteors,
Yep.
Bailey.
Optimus Prime.
All right, so actually they're called meteorites if they're in the ground. So team number 2, yes. So age is based on evidence primarily from rocks from space, because we figure everything formed around the same time. And again, it's that radiometric age dating. Okay, so I got pictures. Where are they?
Did you make sure they were the right ones?
I'm gonna make sure these are the right ones here. I'm not gonna have you guess them. Remember that your meteor is what it is when it's in space. Your meteoroid is the phenomenon of seeing it, right? It's actually the phenomenon of seeing the light. And the meteorite is the piece that hits the ground. And they've been dated with radiometric dating to 4.5 to 4.7 billion years old, billion years ago when they were formed. So we're thinking Earth is about the same age. Yeah.
Would you put those minerals on the inside of the Earth, like core, because that's where the stars come together?
Because what? Yeah, they're all melted, so it would be
But
hard.
If you were like find something.
But they would just be element in that case. So again, we go back to, yeah. So the easiest thing to do if you're gonna date it is to look at something formed at the same time. Okay, why do scientists consider we just talked about this, I already said it. Okay, they think it formed at the same time. All right, who we're on? Team number 2?
Yeah.
Okay. Now, when you explain this, I want you to be specific. So you've got your earliest atmosphere, which was composed of what first? Hydrogen and helium, and it's going to be replaced by oxygen, nitrogen, and carbon dioxide. Why specifically did they replace it? Not just how they get there.
Okay, so, first.
Yeah.
we'll hang out, Jeff. I'm just gonna add
Hang on.
Nitrogen, carbon dioxide, a little bit of oxygen, that's not important here yet. That's not really what that's from.
Mhm.
Then, there are a few things that happen. One is helium and nitrogen are just gonna fly away.
Yes.
Again, we don't know where it went, probably space.
Guys, hang on, Parker,
We don't
Chloe.
know where it's gone. This is kind of.
You're right. But why did the hydrogen and helium just fly away?
Because they're so minusculely tiny.
That's the point. This is the point.
And then there's also cyanobacteria.
We'll get to that in a minute. So this is exactly the point. So we've got this earth, right? It's cooling. There are areas in the crust that are thinner. We have volcanoes and they're outgassing. And they're putting out carbon dioxide, nitrogen, stuff like that. Those molecules are way more dense than helium and hydrogen. So those molecules displace, keep that in mind, they displace the lighter ones because these are so much heavier. So look here, see their densities here? And when you actually put the molar mass, which we did when we went over this lesson, we actually did the molar mass of all these, and you see that they're much, there it goes, much heavier. Nope,
Okay.
you don't need to know the molar mass, but if you can explain to me not just how they got there, not just, well, there was outgassing, okay, but why, what does that have to do with why the helium and hydrogen are gone? It has to do with the more dense molecules displacing them. All right, so team number 1, the number that any given environment can hold is referred to as, it's right there, Drew. Yeah, it's right there. All right, carrying capacity. Team number 2. So this is solar energy production. Combination of lightweight atomic nuclei into heavier are what? What is that? When you put lightweight atomic nuclei together to get a heavier one, Chloe? That's fusion, right? We're not going to confuse fusion with gravitational contraction again, are we? No, we're not, Miss Danny. We know the difference. Whoop. Okay, this is where Alex was going a minute ago. All right, so team number 1. You got your volcanoes. We talked about how they were producing nitrogen and what? What was it, Liam? Carbon dioxide. So now we have a source of atmospheric carbon dioxide. Shh, hush, back there. Don't talk. So Caitlin, then what do we have? Cyanobacteria. That's right. And what are they producing? Well, they're green. So what does that tell you, Drew?
They're outgassing oxygen because of
Yeah. Yes, good. They're green. So they undergo photosynthesis and now they're producing oxygen. So this presence of oxygen is going to allow for organisms to evolve that undergo what, Bailey? Respiration. So that's how we get here. Very, very good. Yes.
I just want to say, I did most of the work for them, so.
All right. We're getting towards the end. All right. Now,
I can't even read that and ever hear.
I'm going to make it a little bit bigger. So these are your different types of energy. What involves, we had this on a test, involves unsightly apparatus, requires large surface area. Not all areas are favorable due to topography, typical weather patterns. Chloe? Yeah, wind. Okay, very good. And not go? Oh, it won't click. Hang on. There it goes. Wind power. All right, it's your team. So requires large surface area, may pose a threat to avian species. Not all are favorable due to latitude. That solar. Yep. Remember, listen, remember wind power does cause a threat to avian life, birds, right? But the latitude is the giveaway here, right?
And the solar power cooked it.
Yes, exactly. All right, team number 2, you're still going. What requires proper topography and the presence of moving water? Jack?
Hydropower.
Okay, and how about what's limited to extraction in specific areas and improper transport can result in land or marine pollution? Chloe? Card? Anybody back there got it?
Fossil fuel or oil.
There you go, oil. Yeah, oil, fossil fuel, oil. A lot of these are fossil fuel. All right, so accidents, though rare, can result in total devastation lasting decades at a minimum, guys. Yes? Chernobyl, which was what? Nuclear. And am I going to disown anyone today?
I can't pronounce either.
Nuclear.
I can't pronounce either way, so.
Ah,
So I'm just not gonna say the word.
all right, team number 2. We're still on team number 2. Okay, mostly available in areas of volcanic activity. What's this? Say it, Jack. Say it. You're thinking it.
No, I was trying to make sure I said stupid.
Oh,
What's the thing? I can't remember.
mostly available in areas of volcanic activity. Not your team, Drew.
Big ones is like geothermal.
Boom. Okay. Highly flammable. Pipelines can be expensive. What's this one?
That was the part down
This
for
could be natural gas, by the way.
That's what we're looking for. And then what can cause lung disease in miners? Coal. And then lastly, can destroy habitats or disrupt the food chain by removing producers from an ecosystem, Chloe. Biomass. Good. All right. Moving on. Respiration and photosynthesis. Team number 1 are what? Opposite chemical reaction. Team number 2. Getting closer to the end here. All right. Tools of astronomy and radiation. What is this? I forget how loud he is every time. Your electric and magnetic disturbances traveling through space. It's this thing right here.
Electromagnetic radiation.
Yes. And then what we say all types of electromagnetic radiation arranged by wavelength and frequency.
Electromagnetic spectrum.
Right on. Okay. And moving on, team number 1. Okay, gravity is the attractive force between 2 objects. So we're going to do Newton's universal law of gravitation first. Newton's law of universal gravitation is usually stated that every blank particle,
It has an outline.
I know it's not quite centered, attracts every other particle in the universe with a force that is what? Proportional to the product of their masses and what?
And direction proportion.
Inversely proportional. Okay, that's 1. I'll let you keep going. Gravity and orbits. Blank discovered that gravity explains why planets move. Very good. And center of what is the point between the planet and the sun, or just above the sun's surface, that's actually orbited? Then we're going for it. Bingo. All right. Good job. Team number 2. Natural resources are provided by what?
Nature.
Jack? Specific, yes, nature, but what is that? Well, I'll get, okay. Earth, I'll give you nature. Okay. What kind of resources are replaced by nature in a short period of time? Milo. Yep, renewable. And what is the act of replacing the resources at the rate at which they are used? Sustainability, right? And then this is all off kilter for some reason, but sunlight doesn't need replacing, has 5 billion years to go, which is why it is considered renewable. Okay, Earth, Moon, Sun system, synchronous rotation. Is the moon spinning exactly once as it orbits? What do we call it when the moon is becoming more visible and less visible? Team number 1. Yeah.
Waxing is becoming more visible, waning is becoming less visible.
Right. Now, if I were to give you a diagram that looks kind of like phases of the moon, would you be able to identify them? If your answer to that is no, go home and look it up. Yeah.
For that, at the first quarter half moon, or could we just say half moon or like first quarter?
You could say half moon, but preferably first quarter, because the third quarter, or 3/4 as they wrote here, is also a half moon. So which one are we speaking of, first or third, right? So it'd be more accurate to say first or third. Yeah, that's Conventional energy resources. What are materials consumed to produce energy back there? Fuel is right. And number 2, what kind of fuels are derived from living things? Yeah. Biomass fuels. You got it. Okay. Conventional energy resources. Team number 1. Formed over geologic time by compression and incomplete decomposition of organic matter. What are these? Think about it. Piper, you thinking about it? What do we call this? Conventional sources. Like pictures of them here, y'all. Woo! What are these, Drew?
Well, so it's gonna be like fossil.
Fossil fuels.
Yeah, fossil fuels. Do you remember this thing? Remember this guy? The eternal flame? I want to go hike that trail and see it. Hey, dudes in the back. Alternative energy resources. Energy from water. What converts energy of free falling water or flowing water to generate electricity? What is it, Jack? Hydroelectric. And was it gonna go? Oh, what are these doing? I don't remember. There you go. And energy from the ocean in particular. What do we use? Tidal, yeah, or waves. I'll take either one of those. Alternative energy, we're still on it. What produces energy from naturally occurring heat, steam, and hot water? Team number 1. Yep. You could do hydrothermal, but geothermal would be more accurate in this case. Yeah. Hello. It's got pictures for all of these.
Hydro.
Well, because you can use, because the water, yes, you can use like the naturally occurring steam, which is hydrothermal, but that's created because there's geothermal heat beneath it, right? So we're looking really for geothermal. Hydrothermal isn't necessarily wrong. Okay. So windmills and wind turbines convert wind energy to power. This is what? Wind energy. And what produces energy by nuclear fission? Nuclear. Remember, nucleus, nuclear. I don't want to disown anybody. And then, oh, these are off. That's supposed to be biofuel and biodiesel. I'll fix those. But biofuels are based on ethanol. Biodiesel comes from vegetable oil. I got to rearrange that slide. Okay, in the back. Alternative energy resources. We have different kinds of solar heating, right? Okay, so what kind of solar heating is the windows, walls, floors, James? Passive solar heating. Whoop. There we go. And what uses the mechanical aspects? Active. And then what's this last one? Converts solar energy to electric power. Anybody remember? Guys in the back. So photovoltaic is the word you're looking for. Break that one down. Remember, voltaic has to do with what?
Voltaire.
Not Voltaire. Volts, energy, right? Photo light. There you go. All right, sun, moon, earth system, tools of astronomy. Let's look right here. Distance, team number 1. Distance between identical points on consecutive waves is what? Wavelength. And it's going to make its little thing here and say, woo, there it goes. It's going to show them to you. I don't know why it's showing them to you now. Should have showed them to you earlier. Okay, wavelength is correct. And the distance between the origin and crest is amplitude, and your distance between, your number of points that pass the same, number of times the wave passes the same point is frequency. Very good. All right. Lunar motions. What is it called, team number 2, when the moon passes directly between the sun and the earth? What is it?
Solar eclipse.
Okay. And what is it called when the moon is near apogee and appears smaller and will not completely block the sun?
Partial solar eclipse.
That one's annular. So then this one will be partial. Oh, sorry, lunar. And an annular eclipse is this specific type of partial. So I won't not accept it. That's fine. I want you to be sure you know, like, that a solar eclipse is the moon passing between the sun and the earth, and a lunar eclipse is the moon passing through Earth's shadow, right? Solar is when the sun is being blocked. Lunar is when the moon is being blocked. Does that make sense? Yeah, a little bit. Okay. Oops. And you don't have to know those. Those are not going to be on yours. All right. What resources exist in fixed amounts on Earth, team number 1? Yep, non-renewable. Fixed amounts on Earth. Oh boy, team number 2. What is the apparent backward motion of a planet Retrograde. And okay, inspired search for better understanding of planetary motion and the move from what kind of a model?
Geocentric to heliocentric.
Geocentric to heliocentric. Very good.
It's accurate, it's only accurate at a local scale, it'd be.
Yes, you stretch out beyond our solar system, then we're, yeah, yep.
It don't work.
Okay, and that was Copernicus, right? Kepler's first law of planets orbit in an elliptical pattern. An ellipse is what kind of shape?
Rounded
Oval.
egg-like shape.
That's good. And an astronomical unit is Earth's distance from the sun, which is, anybody know?
Wait, isn't it just given to her?
1.4. I was trying to see if we could get any of the number. You don't need to worry about it. That one's not on the test. Okay, and what is that's supposed to say ratio? Oh, I didn't correct that here. Of the distance between foci to the length of major axis. This one's not on the exam, but do you know it? Eccentricity. Okay, Kepler's what law states that planets move faster when they're closer to the sun? And that was second. And then what's this one going to be? Third is that planet's orbital period is the length of time it takes for a planet to make a complete orbit around the sun. And then lastly, who was the first to use a telescope? Galileo. There we go. All right. Team number 1, groups of stars. I'm watching our clock here. Okay, groups of stars, figures that are formed by stars in the sky are called what? Constellations. Some are visible throughout the year, some at only certain times of the year. What are fewer, what do we call them when they're gravitationally bound and appear closer together due to extreme distance? Yeah, there you go, star clusters. And what do you have when you have 2 gravitationally bound stars that orbit a common center of mass? Binary, good. She answered one for me. Yep. Oop, don't worry about that. Nope, stop. You got it. And then lastly, Doppler shift. This is in your way, so I got to read it to you. Remember that your Doppler shift is when your spectral lines shift as it moves farther away. You're going from reds to blues, blues to reds, depending on whether it's getting closer or away. And that's the end of those. So now we get to move on to now remember to whoa. Remember to okay, gang. Nice. Remember, we're gonna keep it quiet. Who had the most points coming out of that?
One good,
Okay, so tied up basically.
basically.
Okay.
Another question. I'll put it aside.
5 and 30.
Does anybody need like a 2-minute stretch break?
Because of the times of each, because there was like 3 questions of each 5 points.
That wouldn't have put us both up. That would have kept us equal.
I don't know, that's what I had.
Yeah, you're
37,
off. You can get 36 with my company.
My gosh, y'all are insane. Okay, so we are gonna roll through these quickly because I still have your surprise lab / project in here.
You should be at 36.
All right, it down there. So we'll do this as team number 1 answers the question. We'll start with them because they're down a point according to Alex.
No, we're down.
Oh, you're down a point, then we'll start with you. Okay. So we'll start with you. And instead of bouncing the question to the other team, if you don't get it right, we're just going to count it as wrong because I'm watching time and I want to make sure we have time to get through all of it. Okay. So team number 2, you guys call one person to do the picking. Decide who that is. Team number 1, decide who your person is that's going to say what you're doing. Okay?
You're in the hot seat.
All right.
All right.
Do you have your designated answerer?
She is an answer.
Okay, I can't even hear him because everybody's talking.
Energy for 700, he said.
Wait, is it him or you?
It is.
Okay, then you guys need to be quiet so we can actually hear him. Energy for 700. Team number 2. This requires large surface area, may pose a threat to avian species. Not all areas are favorable due to latitude. What is solar energy? And you are correct. Excellent. Team, what? I always miss this button. Okay, team number 1.
Final frontier for 700.
Final frontier, 700. This explains why spectral lines shift as stars approach and move away, and why the pitch of a police siren changes as it approaches and retreats.
What is a Doppler shift?
What is Doppler shift? Correct. Team number 2. And remember to do what is, okay? You're up.
That's the question.
Answer in the form of a question. What are we picking?
Yeah, you're already choosing.
How to Science 700. An open water bottle is an example of this kind of system. Y'all figure that out.
I forget, what is an open system?
What is an open system? You are correct. Team number 1.
Let's do
Mhm.
the potpourri for 700.
Potpourri for 700.
Not Cooper.
These are the steps through which Earth's atmosphere changed from its early composition of mostly hydrogen and helium to one suitable for organisms that undergo aerobic respiration.
Outgassing.
Okay, yeah, what is?
What is outgassing? Then the cyanobacteria producing the oxygen.
Okay, hold on. Be a little more specific. What about the outgassing?
The outgassing release the CO2 and then the water vapor that.
Mhm. Don't forget to address these
and
two
then
right
the
here.
hydrogen and helium flew away because their masses were too little for
Mhm.
limited early.
Right. Are you listening to her? Uh-huh. You're right. They got displaced. Yep. And then you had
The
cyanobacteria evolved because there was carbon dioxide. Yep. And then
Oxygen.
right on. Yep. So there you go. Early atmosphere, hydrogen, helium, outgassing produced heavier gases. First ones were displaced. Cyanobacteria evolves in those big stromatolites, right? Those big mats. And that caused atmospheric oxygen. And then cyanobacteria's contribution to atmospheric photosynthesis, because that gave us oxygen. So then you have aerobic respiration. You guys got that right. And moving on, team number 2. Oh, Earth and our neighbors, 700. Okay. These are the planets in our solar system in order from closest to farthest from the sun. Easy one.
What is Mercury? What is Venus?
Just what is once is fine. You don't have to say it for everyone. What is Mercury, Venus, Earth, Mars?
Is Jupiter, Saturn, Neptune, Uranus, and then Pluto.
Wrong. You had Uranus and Neptune flip-flopped. Yeah.
Because you're on a roll.
All righty, team number 1. What is blue planet? Guys, be listening. You're going to miss answers that are a review. So 700. This is the second leading cause of weather-related death. What is flash flood? There it is right here. Flash flood was your second one. Very good. Team number 1.
Remember that.
Team number 2. Earth and our neighbors, 700. Wait, this was already wrong. Wait, you already did it. I need to say, oh, wait, I needed to give it this. Hang on. Now it's gone. Okay, now you're up. Finding your way, 700. This is located at roughly 180 degrees longitude.
What's long? It's long.
It's not.
What is the international dateline? Is correct. All right, team number 1.
All around you for 700.
All around you for 700. Earth's atmosphere is about this % nitrogen.
What is 78?
Cause I mixed the one.
What is
and eight up.
78%? Oh, wait, nope, that's this, you guys. Very good. Team number 2.
I know that. I'm just lost. I come back to this.
James. You actually could come back.
Oh, we dropped eight on down. Well, yeah, but then we also got one drop.
Okay, breakdown, 700. Y'all, stop talking. Okay. The process by which a stream erodes away at the rock and the soil at its headwaters in the opposite direction that it flows is called, what is headward erosion? Good deal. All right, team number 1.
Rocket for 700.
Rocket for 700. Ultra basic rocks are high in this element. Somebody. Drew knows apparently. He's dancing. Piper?
What is iron?
What is iron? Correct. All right. James, we're going.
You answered the moon phase
Oh,
when you both had
Fair
different.
weather, so.
Fair weather, 700 of 10. All right, here we go. This is what a tornado might look like on a weather radar. Oh, what is a hook, he says. And he is correct. What is a hook? Yep, very good.
I was like a little hook.
Mm-hmm. Yep. All right, team number 1. Get a move on for 700 for the last of the 700s. Okay, these are examples of evidence of seafloor spreading. Give me a couple.
Okay, so,
91.
yeah.
What is mid-ocean ridges?
That's a good one. Yep. Basically, you're going to look for things like magnetic striping, mid-ocean ridge, this whole kind of process. Yes. Which question?
Never mind.
You got it?
Yeah, it worked out in my head.
Okay, did I give you? I didn't
Not
yet.
yet.
There you go. All right, number 2, where are we going?
Energy 600.
Energy, 600. This can destroy habitats or disrupt the food chain by removing producers from an ecosystem. What is biomass energy? Correct. Team number 2. Number 1.
Blue Planet 600.
Blue Planet, 600. Seawater has a salinity of about this percentage.
I think it's 160.
Hey, volume, bring it down. Guys, if you were loud, we can't do it. Yes. What is 3.5%? And that is spot on. Very good. Okay. Shh. Okay, team number 2. How to science for 600. Keep in mind, if you get loud, we can't continue. He has to work, so we have to be respectful of that. This tells what happens a fact. This tells why it happens an explanation.
What is scientific law? What is scientific?
Very good. Scientific law and scientific theory. Very good. Next up.
All around you for 600.
All around you for 600. This type of a substance is derived from living things. Come on. Somebody say it.
Oh.
What do you call something that's derived from a living thing? Organic. What is an organic substance? Very good. Okay. Number 2.
That is a question. What is life?
It's a great
Get a
question.
move, but I know the answer.
What is it? Get a move on. 600. Shh. Okay. The African plate at the Eurasian plate forms this type of boundary. What is a convergent boundary is correct. Okay. Team number 2. Sorry, number 1. Where are we going?
Fair weather 600.
Fair weather, 600. This deflects air to the right in the northern hemisphere.
Right northern hemisphere. Coriolis. What is a Coriolis?
What is the Coriolis effect? Correct. Very good. Team number 2.
Final frontier for 600.
Final frontier for 600. This evidence exists to support the theory of the Big Bang and the concept that the universe is continually expanding.
Software effect.
Yep, I'll take that one. Basically, there's the whole idea. Retrograde, Hubble's law, Doppler shift. These are the big ideas, okay? Remember that these are the big ideas. Oh. All right, number 1.
Rocket 600.
Rocket, 600. Large crystals in a rock demonstrate this.
What is slow cooling?
What is slow cooling?
Yes.
That is correct. All right, number 2.
Breakdown.
Breakdown 600. This is a long and winding ridge of sediment formed from streams which live beneath a glacier. What is an esker is correct. Very good. Team number 1. Find your way, 600. When traveling westward by ocean, sailors take advantage of these equatorial winds. What is trade winds? Very good, Drew. Your team can't see you back there, so you may want to move over here. And if you know, then you can say you know, and they can actually hear you. Alrighty, team number 2. Where are we going?
Oh, that's one.
Yep, that's you.
Earth and our neighbors, 600.
Earth and our neighbors for 600. This defines the number of organisms that any given ecosystem can hold. What is the carrying capacity? Very good. Team number 1. Potpourri, 600. Okay, this happened when Becky returned home from Denver to her home in New Orleans. This whole thing.
Okay, so
Yeah.
because the lower you get, there's gonna be more air because gravity pulls all the air down. And New Orleans is lower down than Denver is, so it's more air.
Mhm.
So
More
she-
air pressure.
for air pressure.
Yes.
When she went to Denver and she used her shampoo, she got all of less
Denver
dense
air.
Denver air inside of her shampoo bottle.
Yep.
She went back to New Orleans, that Denver air, because it's less dense, got pushed by the denser.
Correct.
New Orleans
Why
air.
didn't her snow globe get crushed?
Because it was
sealed.
Because it's sealed. That's true. It's completely
And
sealed.
there's
It's
no air
also
It's all water.
what's a snow globe made of? Glass, as opposed to my car? No.
Okay.
Not until what time you be back with it? Okay, that's fine. All right, bye. Cool. Now you guys can get a little excited. Okay, did I give you points yet? No, I didn't. Okay, that was good answer, Drew. All right, team number 2. Energy for 500. All right. Bioremediation. What is?
What is when you use organisms to clean up the fire?
Yes, what is what is it when you use organisms to clean up toxic waste spill or whatever like that? Yep, okay, number 1, team number 1, where are we going?
Blue Planet, 500.
Blue Planet for 500. About 71% of the Earth's surface is covered in this. Team number 1. What is?
Water.
What is water is correct.
Water.
Very good. Team number 2. How to science 500. In order for this to be considered, it must be possible to be tested and accepted or tested and rejected. What is a hypothesis? Very good. Remember that accepted and rejected are the correct terms, not proven or disproven, right? All right.
Fair weather, 500.
Fair weather, 500. This is the 3rd leading cause of weather-related death. Who remembers? Do you know?
Rip rides.
What? Oh, wait. Okay, what's our official answer? What are?
Currents.
Okay, what we're going with there. So our 3rd is, yes, rip current, rip tide will take both. That's good. Excellent. Okay, good that y'all remember all those. Alrighty, how about team?
Last year.
Yeah. All right, team number 2, where are we going? Come on, James, where are we going?
Final frontier.
Final frontier 4 or 5? 5? All right, here we go. Frequency, what is it? What is?
It's the amount of times the wave passes through a specific.
Very good. Very good. You said what is. All right, number 1, team number 1.
The far left, far right one for 500.
Potpourri. You hate that word. Okay. These are the phases of the moon, starting with full.
No? Oh. Okay, full.
Wait. Decide amongst yourselves. Okay, wait, she's got it.
And
3/4 half moon, waning crescent, new moon, waxing crescent, first quarter half moon, waxing gibbous.
Almost. I'll give you one more chance. There were two in there that you need to flip. So I'll give it to you because that was pretty darn.
First one, gibbous.
So it's, oh yeah, no, you got it right. Sorry, I had your first quarter and your last quarter confused. 3/4. You're right. You're right. You got it. 100%. That was great. Whew, that was me getting confused. That was a good one, Bailey. All right, team number 2. Y'all aren't gonna get through the whole review. That's gonna be terrible. All right, team number 2, where are we going? Earth and our neighbors for 5. Where the heck is it? Here it is, 500. All righty. Earth is tilted on its axis, and as it revolves around the sun, certain parts of the planet are either closer or farther away from the sun, causing these periods of warmer and cooler weather. What are the seasons? That's correct. Team number 1. Get a move on. 500. An example of this type of boundary is at the Pacific Plate and the North American Plate.
What is convergent?
Because he said it doesn't mean it's a answer.
She's the official answerer unless she designates somebody.
Because yes, transform. Because the Pacific North American.
So what's our answer?
What is it?
What is a transform boundary? Yay! Somebody gonna ring the bell for Liam? The shame bell? Oh man. All right, number 2. Rocket for 500. These are 3 characteristics that can be used to identify a mineral.
What are color, luster, and fracture?
Yeah, fraction plus cleavage.
Okay, those are all good. You can use any of these.
You only have to know.
Crystal form hardness, 3 is what I asked for. Streak, special properties, specific gravity, luster, cleavage or fracture, color. All right, where are you? You're here. Team number 1, where are we going?
All around is 500.
All around you for 500. A solid becomes a gas through this process.
Yeah, but I'm gonna let. No. All right, I'm done.
Who's answering?
It's sublimation.
What is sublimation? Is correct. That was a little video on it. You don't need to see that. Yeah, you gotta love that guy, right? He's super fun. All right, team number 2. He's trying to read. Yo, y'all, stop.
Breakdown.
Breakdown 500. This is the process of the lowering of the land's surface by wind erosion.
What is deflation?
What is deflation? Correct. Moving on.
Find your way.
Find your way for 500. To keep the ocean on the map, it's important not to disturb these windblown sand deposits that separate the beach from the mainland. What dunes? What are dunes? What dunes? You sound like that bird. You know that bird that says, what doing? What?
You had the video up there.
Yo, did I have, yeah. Oh, I forgot to put him in there. You're right. What doing? He's so funny. All right, team number 2. Energy for 400. Okay, shh. Check your volume. All right, this involves unsightly apparatus, requires large surface area. Not all areas are favorable due to topography and typical weather patterns. What is wind energy? Correct. Team number 1.
This is far.
Potpourri, 400. The rate or speed at which a substance will flow is? Say what is? What is viscosity? Is correct. Team number 2. How to science for 400. 1 milliliter is equal to this many liters. Okay. What is 0.001 or 0.001? You got it. Team number 1.
Blue planet 400.
Blue planet, 400. This is a tributary.
What is a stream or river flowing into a larger stream or river?
There you go. Yep. What's a river or stream? Flows into a larger river or stream. Very good. Team number 2.
Earth and our neighbors, 400.
Earth and our neighbors 400. The length of time it takes for half of the radioactive atoms of a specific radionuclide, I think I'm missing a word there, to decay. What is half-life? There we go. All right. Team number 1.
Get a move on for 400.
Get a move on, 400. Hi, Otto. This type of boundary exists at the Mid-Atlantic Ridge. What is a divergent boundary? Very good. Number 2. Team 2. Alex, back up a little bit. Give your sister some air. Say it again. Fair weather, 400. Keep going, Alex. This happened to Becky's shampoo bottle. It got crushed. Okay, what? Again and again, do you think?
On the final,
Might just be there. All right, team number 1, where are we going?
all around you 400.
All around you for 400. Here we go. The law of conservation of energy states this. Lily, you can do it. The law of conservation of energy states, you know it. It only,
Oh my gosh. Something,
they got it. They're helping you. It only changes form, right? What is? Yes, very good. You got it. Sorry, you got it. All right. Team number 2. Final frontier for 400. What's amplitude? What is, yes, the distance between the resting position and the maximum displacement or the height of the wave. Very good. Team number 1. Team number 1. Find your way, 400. No matter where you are on Earth.
Of the air around lightning when lightning strikes.
There you go. What is the rapid expansion and contraction of air due to the heat from a lightning strike? I know that bird is, yep. I've tried everything. Team, I'm going to put some big eyes on the window this afternoon. I found these eyes that you can like put in your windows or put in your bushes for Halloween. And I found them on clearance at Michael's months ago. And I'm going to try putting the big eyes. See, she's mad. She is all kinds of stress. He started it, and then she started following him, and it's ridiculous. But
Wait, Ozzy, stop looking at the floor.
somebody dropped something there. Team number 2. Oz, leave it. Say it again. Rocket, 400. Ozzy, come. This illustrates the predictable pattern in which minerals form as magma cools. Ozzy.
What is Bowen's series of reaction?
There you go. Bowen's reaction series. Very, very good. Okay, team number 1. Breakdown 400. The rate of chemical weathering increases as this increases. What is temperature? Right, very good. Team number 2. Where are we going? James? Energy is James's favorite category for 300. The law of conservation of energy states this. And if I ask you what the law of conservation of mass is, you would say, just substitute the word mass. That's correct. Excellent. All right. Number 1. Blue planet 300. This is the cause of high and low tides. What's the cause of high and low tides? You know, Sky. What is it? What causes high and low tides?
What is the moon's gravitational?
There you go. Gravitational pull of the moon. That is correct. And yes, there. Did it not go?
Yeah, you can count them twice.
Did it?
Yeah, you got 3. No, they should be.
It's only 1. I didn't see it move. Okay, there.
Yeah.
All right. Team number 2. No, just be sure that you understand. Yeah, gravitational pull. Where are we going? Number 2. Beep, beep, beep. Final frontier. Oh, let him do what he wants. 300. The distance between identical points or adjacent crests on the adjacent cycles of a wave.
Leave the bed here.
Somebody give the answer clearly.
Is wavelength.
Are you designated answerer?
Yes.
Okay. What is wavelength is correct. All right, number one.
I want to say rocket.
Yeah.
Which one? How to science, 300. Using your senses to gather information is called this.
It starts with an O. It starts with an O. There you go.
What is? What is observation? Good job, Sky. All right. Team number two. Rocket, 300. Sediment becomes rock through this process. There you go. What is lithification? Whoop, I didn't even click it yet. There we are. Team number one.
Fair weather 300.
Fair weather, 300. This causes seasons. Yep, what is Earth's tilt on its axis? Very good. Number two, team two.
Find your way through 3 sentences.
Find your way, 300. This is located at 0 degrees latitude.
Oh, wait.
What is the equator? Bom bom. Excellent.
The far.
Potpourri, 300. This causes high and low tides. We said this.
Moon's gravitational pull on the tide
Yes.
on Earth.
Yep.
Yep.
This one's a little more specific than the last, but there you go. Okay. And number team two. Earth and our neighbors, 300. He was the first to use the telescope to discover Jupiter's 4 moons, proving not all celestial bodies orbit Earth. Who is? Okay, team number one. Team one, get a move on, 300. This occurs when the downward force of gravity on Earth's crust is balanced by the downward force of buoyancy. Oop,
It's what is isostasy.
but there's something wrong with the question.
Yes.
Oh,
that
no.
was the answer.
Hang on.
I can try to steal it from them.
I actually need to edit it because there's something wrong in the question.
That's on it.
It's isostasy, you're right. But what's wrong with it?
It's one of the words. Oh, the period.
No, not the period. It has to do with this downward force of buoyancy.
Yay.
Buoyancy isn't a downward force, it's an upward force, right?
It's isostasy.
It's isostasy, yes. Okay, but I need to change it. I didn't realize I cut it directly from that. Buoyancy is upward, gravity's downward. Break down 300. I'm waiting for the rest of your team to pay attention. Okay, here we go. This is the progression through which runoff becomes a river. Ah,
What is real Gully Stream River?
wow, look at this. What is Real Gully Stream River? He is right, spot on. That's good. All around you, 300. A substance in this state will have a definite volume, but no definite shape.
What's liquid?
What is liquid? Correct. Team two.
Energy 60 cents.
Energy again. James loves energy. Fossil fuels are an example of this type of resource. What is a non-renewable resource? Correct. Okay.
Blue planet for 200.
Blue planet, 200. All of the area that drains water into a river or a stream is called this.
What is a watershed?
What is a watershed? Is correct. Very, very good. Team two. Hey, Alex and Parker, quit. Team two, what are we doing?
Neighbors 200.
Earth and her neighbors, 200. Fossils are typically found in this type of rock. That is right. What is sedimentary rock? And team one,
Get a move on. Yeah,
get a move on, 200. These provide the basic driving forces for tectonic plate motions.
What are convection currents?
What are convection currents in the mantle? Yes, convection currents is correct. Team two, team two. Final frontier, 200. This is the most abundant element in the universe. What is hydrogen? Boom, moving on. Team 1.
How does science, 200.
How does science? 200. Yeah, dark matter. There you go. In an experiment, this is what you keep the same.
It's the control variable.
Who's saying it?
Through control.
What is your control variable? Yes. Okay. Team number 2. Breakdown 200. Rocks high in this mineral will be less vulnerable to weathering. Okay, what is silica? Very good. Be sure that you're the one that's supposed to be answering. Hang on. Bailey has a question. No, she points to somebody. What were you gonna ask? Oh, okay. I was in the mountains this last weekend and we were at a waterfall. It was a double waterfall. It was real pretty. And you could see quartz veins where the rocks had fractured and quartz veins had filled in. And all of the granite on the outside had worn down and your quartz veins were sticking up a little bit because they're high on silica. Yeah,
I think you would also see that at Beaufort Dam. You drive past-
probably. Yeah, probably. All right, where are we going? Team number, who are we on? You guys.
200.
Fairweather 200. This happens to ice when it gets above 0 degrees Celsius.
I know.
Go for it.
What is it?
What is melting? It is, yes. Very good. And what happens to its volume, by the way?
It increases. No, it decreases.
It decreases as it melts because ice expands when it freezes. Okay, number team 2. Team 2.
What's the word?
Potpourri.
I just all right.
This is the oldest mineral on Earth. What is zircon? Very good.
All around you, 200.
All around you, 200. H plus ions are produced when this type of substance is combined with water.
Yes, okay. That is acid.
What is an acid? Is very good. Very good. All right, team 2. Find your way 200. This type of map is best for studying terrain. What is a topographic map? Very good. Team 1, you want to go for rocket 200? Rocket 200. Light colored rocks are likely to be high in this mineral.
Feldspar.
What is silica? Is spot on. That's our quartz again, right? Right. All right, where are we going, James? Energy 100? I don't know. Yes.
The other team's trying to sabotage the que-
Yeah, I heard him, but you were too smart to answer feldspar. These are resources which can be replaced in a short amount of time. What is renewable resource? Yeah, very good. Hey, team number 2, what was the question that was just asked and what was the answer?
What? In a short period of time, you have to.
Thank you. Does everybody hear it this time? Because not everybody heard it last time. All right, team number 1.
Blue planet 100.
Blue planet for 100. The hydrosphere is this.
What is all the water on Earth?
What is all the water on Earth? In and around. Very good. Team number 2. Okay. Team 2, where are we going for? Where? Earth and our neighbors, 100. This happens when the moon passes through Earth's shadow. What is a lunar eclipse is correct. Good. All right.
Rocket 100.
Rocket 100. Crystals may form from this, evaporation, or magma. What is solution is correct. All right, team 2. How to science 100. This is the approach to seeking knowledge that involves forming and testing a hypothesis in a logical, systematic way. What is scientific method? Team 1.
All right, 1 for 100.
Potpourri for 100. This is the science of using the annual growth of tree rings to date events and environmental changes.
What is dendrochronology?
Dendrochronology. Liam, you awake back there? He's hiding behind him.
Yeah, he's
Okay, he answered a bit ago. And then, I don't know, we rang the Shane Belly head. You okay? You all right? Is he okay? He's hiding. All right, team number 2. Final frontier, 100. The process by which particles combine, causing the massive increased size, resulting in increased gravity, pressure, and temperature is? What is gravitation? See, it's in capital letters. Team 1,
Alright.
break it down, 100. Shh. Wind erosion and stream erosion have these things in common. Give me some examples.
What is they are both liquids?
Fluids.
Fluids. Anything else?
They both do suspension.
There you go. Yep, both involve erosion by fluids, particles moved by saltation, suspension, surface creep with wind, abrasion with water. Same dealio. Team 2. Get a move on, 100. He hypothesized that the continents had once been joined in a single supercontinent called Pangaea. Who is Alfred Wegener? Oh, good. Alfred Wegener. There he is. Okay. Fair weather, 100. The gases surrounding Earth are known as?
What is the atmosphere?
What is the atmosphere? Very good. And team 2?
All around.
All around you, 100. This is the most abundant element in the universe. What is hydrogen is correct. And we're going to finish it up. Team 1. This is the geosphere.
What is the physical earth?
What is the physical earth is the exact answer. And we end here. Pretty good. It was only because I was 1. Y'all missed the 1 and you bounced out. So good deal. Okay. Now we have a fun.
Is that we put in?
Yeah. Yeah. That works. Uh-huh. Okay. So
We needed that to mess.
we have about 38 minutes, which should be enough time for this project slash lab slash thing. Now, first question is an important question. Do you like this little black and brown fuzzy thing here?
Yeah.
Okay, so therefore, no, that means you have to be extremely careful. So here's what you're going to do. You are going to create your own. You can have northern hemisphere or southern hemisphere. You'll have your choice. These are constellations. These are map pins. If you drop a map pin, everything stops until you find the map pin because it'll end up in his foot or mine. You probably don't care about me as much, but it'll end up in his foot and that would be terrible. So what I'm providing you with is, ta-da, an example. I'll stick it there. These rubber bands glow in the dark. So does the puffy paint. The pins do not. So this is puffy paint, all the dots. Those are the little stars. So what you have to choose from are northern and southern hemisphere discs. I'll put those down over there. Now there are several ways to go about pushing in the pins. I have the little hammers. They're kind of loud. But I also have, probably easier than the little hammer. Listen, I have little thimbles. That's probably easier. Just take a thimble and punch it in. Because you want to go through the piece of wood into the cork. Okay, there's a thin piece of wood and then there's cork. I'm gonna put all this on the counter. I have hooks that you can use to pull the rubber bands around with. Okay, I have puffy paint. Don't get this on my furniture. Okay, and then I have lots of these. And I have tons of different color mat pins. I'm gonna put everything on the counter. I also have little cups and you can fill your little cup with some pins and some rubber bands or whatever it is you want and take them to where you want to sit. You need to be at a table. So you can be there, you can be in the dining room. If you sit on the floor, you can work at this table or you can work at the counter or the pub. If you want to go outside, you can also work outside. All right, so I'm gonna set them up and you guys can come take and have fun. Let me get all this up there first.
I know, I'm like.
So I can take it to the counter and then I'm gonna put those things over on the counter. So I'll do that. Yes. Yeah. Okay.
I'm already.
Gotta walk. Okay. Come around this way.
It's like the Mario hat. Or not the Mario hat, no.
Okay, we have bronze, red, pink, purple. It's different pink, white, blue, orange. Don't mind the labels of something else. Green, different green, yellow, silver, black, different blue, gold.
They're right in front of you. Look up.
One of nine glow in the dark mixed up colors. We're gonna do little scared glows, yes. This is true. Then we have northern and southern. I believe that one was southern, northern. What? Oh. This one, southern,
Order in the court.
So for real, the little thimbles are much easier.
Or we can
And
put sides.
Yeah, but I didn't use the hammer to use here.
So we just
You just tap the pins in wherever you want one to go. And then you can use these little hooks if you need them to help you with your
don't want any half.
and I'll open up the hands too. I tried the hammers and the thimbles, and the thimbles were way faster and way easier. So
Is it more fun? Hammer.
yeah. Yeah, no. Yeah. The thing with the hammer, is sometimes they bend their pins, so you don't wanna bend them.
Where are the hammers? Oh, never mind, okay.
Are you serious? No. To the pub. To the pub.
Bands that you use to make bracelets.
They are,
Okay.
yeah, they're the loon.
Are these no
It's messed up.
White and yellow for stars.
There you go.